Hey guys, what's up? My name is Gabe and this is Games with Gabe. This is the next tutorial in the Coding a 2D Game Engine in Java series. So in the last tutorial we got to was we set up some event listeners so that we can listen to key events and mouse events. And now we have that cool little fade to black thing. We're going to actually use that fade to black thing to do something useful now. I know I said we weren't going to really be using it, but this is also purely just if you want to at the end of the video. What we're going to be doing today is setting up some scene managers, and we are going to be setting up the delta time variable. So delta time variable is very important because we pass that to the game to let it know how much time has elapsed since the last frame, which you can then use to time different game objects and stuff. And if you need like sprite-based animations is a good example. If you need them to run every 0.2 seconds, you can use that delta time variable to track that and make sure that you have that running every 0.2 seconds. And then we're also going to be setting up the scene manager, which is going to be helpful because that will help us separate our game logic from our platform layer. The window is our interface between our game and the operating system. So that's sort of our interface between the platform. And then our scene is sort of like our game code specific stuff. So nothing operating system specific should live in the scene. That should all be game code specific stuff. So let's get that done real quick and see how it goes. So before we start coding the time, I do want to go over some things with just like units and how we're converting. So we use this function called nanotime, and what nanotime is a function given to us by Java that uses the system to get our time in nanoseconds. Now, there are 1 times 10 to the 9th nanoseconds in 1 second. So that means if we want to figure out how many seconds elapse in 1 nanosecond, we would just flip this. So then we know that there is 1 times 10 to the minus 9 seconds for every 1 nanosecond. So this is just flipping it. And the reason we're doing this is because it's easier to think in terms of seconds than it is to think in terms of nanoseconds, because we have these units of measure like frames per second, and we have these other units that we want. When we think in time in games, we're typically thinking on the order of seconds. We're not thinking of the order of nanoseconds or milliseconds or anything, because it's just easier if you are, say, doing your sprite-based animations. You want to think 0.2 seconds. You don't really think, I need around 200 milliseconds. So it's just a little bit easier that way. And I don't even know if that's the right conversion that I just did in my head there. But then once we get our 1 times 10 to the 9 seconds, we know that's how much is elapsing each time. So we just need to multiply this by 1 times 10 to the 9th to get our time in seconds. Then if you want to convert this to like frames per second, well, frames per second is literally just how many frames are there per second. So that means you want to do frames over second. And so when we get our delta time variable, we know our delta time variable dt is the amount of time that happened in 1 frame. So it's seconds per frame. And so if we want to get from here to frames per second, once again, you would just flip it. So you do 1 over dt equals frames per second. And so that's how you would do that conversion, which we will do also just so that we can see how fast our game is running once we get that delta time variable in there. So I hope this quick explanation was a little bit helpful, but let's go and actually see how it works in the code, because I feel like that's always a little bit easier for me to understand than it is seeing the math behind it. So let's do that real quick. Like I said before, we're going to need our time variable. So let's start off by creating a simple class that will get us that time variable. And we'll just put a new package here, and we're going to call this package util, which is where we'll put things like constants and other things of that nature. And then inside this package, we're going to create a new Java class, and we're going to call this time. Time is literally this super simple class that we use just for the delta time variable. You might question why it's even useful, and I'd say just because it's nice to wrap things up so that you know exactly what's happening there. Now, what we're going to need is we're going to need a public static, I'm going to call this a float, and this is going to be the time started. So this is going to be the time that the game actually started. We're going to call it system.nanotime. Now, static variables are initialized at the application startup. So all of these are initialized as soon as the application starts up. So we know this is going to be the time of the application start, which is nice, and then it's never going to change after that. So then we can use that in conjunction with our function called getTime to find out the time elapsed in seconds from the time start of the application. So then we'll say return, and we're going to cast this to a float. We're going to say system.nanotime, which is the time that we're at now, minus time started. And then we're going to say times 1e to the minus 9, just like I showed you to convert from nanoseconds to seconds. And all this is doing is it's saying return the time that we're at now, so nanotime now minus time started, which gives us the distance. So this is the time elapsed since the application started, and we convert that to nanoseconds. So really simple, just the time since our application started. Now let's actually use this inside of our loop. So how do we use this inside our loop? Well, we get a couple variables. We'll have our float last time, so the last time that the frame ran, and we're going to call this time.getTime using our little helper function. Actually, let's call this begin time, so the time that the frame began, and then we're going to call this one float end time. This is the time that the frame ended. And so actually, we're going to initialize both of these out here, and then we're going to say GLFW pull events, clear color, all this stuff. And then right here at the end, what we're going to do is we're going to say, okay, so dt is end time minus begin time. And we'll actually get end time here again. So we'll say end time equals time.getTime. And then after that, we'll say begin time equals end time. And then next time we come through here, dt will be the next time elapsed. So what happens here is begin time is initialized here. It's the time at this point. We go through, we run our entire game loop. We get to here and we record the time that we're at right here. We subtract the end time from the begin time, which happened here, which gives us the time elapsed that it took to do all of this stuff. And that's our delta time. Then we say begin time equals end time. So now begin time is here. It loops back around, and then end time gets the time again, and once again it's the time that it took to get from here all the way back around to here. So dt always contains that looped time. And the reason we're doing it at the end here rather than at the beginning is because what if your application goes through here and then the operating system calls some other function? So then you get a lag spike in your game. If you called begin time up here, you would just be recording the time it took to cross over here, when in reality the operating system interrupted your game, and it actually took a couple of milliseconds out from here to here, and then those milliseconds added up inside of here. So if we get our begin time here, we're ensuring that any interrupts or anything that happens too will also be recorded by our game, just so that we can detect lag spikes and stuff like that. Now this begin time, end time, dt variable, they're all kind of useless if we don't have an actual update loop. So we need to start our scene manager so that we can have some update loops. So let's go into here, and what we're going to do is we're going to create this class called scene. And so this scene class is going to be abstract because it's going to implement a couple methods that we would like it to implement. And for now, what we're going to say is public scene takes in nothing. So it's just simply a empty constructor. And eventually this is going to have a whole bunch of things. It's going to have the game objects, the render, the physics handle, all those different things is going to be contained within the scene class. And so it's going to be sort of, like I said, our big game wrapper. And then what we're going to do is we're going to create an abstract method. So public abstract void update. It's going to take in a float delta time. And so this is where we're going to pass our update method. And then it'll go into the scene and update whatever it needs to update. Now we're going to go into here, we're going to create a new class called level editor scene. So this is going to be our level editor scene where we're actually editing levels, and then we'll have another scene called level scene where we are playing the levels. So hopefully that's pretty self-explanatory. And level editor scene, once again, we're just going to initialize it and create the initializer with nothing in it for now. And then inside of here, we're going to implement that abstract method. So up here, we'll say this extends our scene object, and that's going to say you need to implement that method. So I'll hit Alt Enter, and we will implement that method. Now we can use this dt variable, so we can update according to delta time. And so now we're going to use this to transition from level editor scene to, and then we will go create another scene, level scene, and we're going to make it fade to black over 2 seconds. And I'll show you how you can change that and stuff too. So we're going to create this level scene, also an empty constructor, and this is also going to extend scene. And so these are going to be like the two main scenes we're going to have. I had one other scene called test scene that I didn't really end up using too much, so we'll think about adding that because it might be nice if you want to keep some code. around, which is what I used it for when I was testing things and stuff. So now we have this scene, we have this test scene, and we have we have a level scene and level editor scene. Let's go to our window, and we want our window to be able to change between scenes. So we will have a private static scene variable, and this is going to be the current scene. And we're going to initialize this to null. And actually, let's make this an integer. So it's going to be an integer variable. And then we'll just initialize this to -1. So then we're going to have a public static method in here, void, and it's going to be called change scene. And we're just going to take it in an int variable, and this is going to be the new scene, the scene that we want to change to. Then we will switch on that new scene, and we'll say case 0 will make a new level editor scene, and I'm going to say our current scene equals new level editor scene, and we will make this a private static scene variable. And then we'll just call this current scene index, because actually we don't even need this one. Yeah, we'll just have a current scene. I'm sorry. Trying to just write this from scratch. So we'll just have our current scene, and then we'll have this integer which tells us which scene we want to switch to. So then we'll say current scene equals a new level editor scene. I feel like I'm spelling these wrong. I don't know. It just looks really weird now. I think that's right, but if it's not, then that was an accident. So then we'll say current scene dot update, or init or anything like that you would have happen, you would do right here, just so that we have that working, and then we'll break. Then we'll say case 1 current scene equals new level scene. And then once again, you would do your init or anything like that. And then for our default case, we'll just assert false, and we'll say unknown scene. Now this isn't going to do anything, and then we'll just say like plus the scene's index that we're trying to pass in. This isn't going to do anything yet because we don't have assertions enabled, but we will enable assertions, and this is how we will do this, because it's actually really nice to have these in our game. So we have all these different things, and then let's go into our level editor scene, which is where we're going to be starting. And then inside our update method, we'll say if input, if key listener dot is key pressed, and we're going to say key event dot vk space, and then we're going to say if not changing scene, and we press the key. Then up here we're going to add in a Boolean variable, which is going to be private Boolean changing scene equals false. And then inside here, we're going to say changing scene equals true. So if we are changing the scene, then we want to slowly decrease the opacity, just like we did in the color to black, so that it fades. Then we'll say if changing scene. Then we will do another variable up here, which will keep track of how long it takes to change the scene. So float time to change scene. I'm going to initialize that to 2 seconds. So this is how long it's going to take us. If changing scene and time to change scene is less or greater than 0, so we still have time left. And then we're going to say else if changing scene and the time to change the scene is less than 0, that means that we've finished fading and now we want to actually change the scene. So we'll say window.change scene to 1, which will change us to the level editor scene. And then inside here, what we're going to say is time to change scene minus equals dt. So we take away the time that's passed in the last frame. And then we're going to just update the Windows RGB. So we're going to say minus equals dt times, we'll do like 5.0f, window.get.r or g minus equals dt times 5.0f. And then window.get.b equal minus equals dt times 5.0f. So this may not fade exactly perfectly, but it will give us the 2 seconds that we're looking for. Let's go to our window real quick, just make these public right here, just so that we can access them for now. This is not how you would do it normally too. This is not the best way to do it, but it's whatever. And then let's take out this key event that we were handling inside here. So we'll take out the fade to black thing. And then right down here is where we're going to update using our DT variable. So let's actually initialize our DT variable out here. We'll say float dt equals 0.0f. Actually, we'll make this negative 1.0f. And then what we're going to do is check and see if we've actually done a frame yet. And so right here, we will say current scene dot update dt. And then right here, we will not duplicately initialize this. And then right here, we'll say if dt is greater than 0, greater than or equal to 0, we will update. Otherwise, we won't. So that way, when we first go through here, we do not update because there's no time, right? dt gets initialized down here. And then next time we go through, we get the actual dt, and then we can update our scene. So it's like a lag of 2 frames. We're not actually going to start updating our game until 2 frames later, which is fine for now. If it becomes a problem, we can check and see how to fix that. Now let's go into here, and then we'll just say system.out.println inside level editor scene. And then we'll go into our level scene, and we'll say system.out.println inside level scene, just so that we know if it is working and we are switching scenes. So if we start up our game, we're going to get an error here. And current scene is null. We never changed our scenes. So what we have to do is after we initialize everything right down here, we should say window.changeScene 0, just so that we make sure we are in a scene before we actually start our game. There we go. Then we get our window. If I hit space, it fades to black. And then after about 2 seconds, it should be white again. Actually, it might not be white again because we're not changing the color on change scene. But if you look down here, it says we were inside level editor scene, then inside level scene. So we did change scenes. And then what we can do is inside level editor scene, or level scene. Once we initialize, we'll say window.get.r equals 1, window.get.g equals 1, window.get.b equals 1. And now that should give us a white screen once we switch scenes. And if we wait, and then it changes back to white. So we now have a successful scene manager and a window that can handle the changing of the scenes. And we have our delta time variable, which is working as we would expect to. If you want to see how many frames per second you are running at too, like I said earlier, you can just print out 1 over dt, which should be your frames per second. So if we go down here, we can say print line, and then we'll say we are running at, we'll just do that, plus 1 over dt, and make sure this is a float, because otherwise you will be doing integer division, plus FPS. And if we run this one more time, we should see about how many frames per second we're running, which is going to be pretty ridiculous because we are not currently doing anything right now. And so then if I go, oh, actually, that's actually pretty normal. So 59 frames per second typically, and then 119 frames per second. And this is actually a good point too. The reason it's so uniform, which is really good too, we want it to be uniform, is because it's locking to the refresh rate of our monitor. So if we go back into our window, remember, we did this whole swap interval 1 thing, right? What this does is it locks our frame rate to the interval of the refresh rate of our window. GLFW does some stuff underneath the hood. That way we get a pretty uniform frame rate. Now, you get some spikes down and up, but for the most part, you are running at a solid 60 frames per second or whatever the refresh rate of your monitor should be. So we can now see how many frames per second we're running at and stuff too. All in all, what we did is we simply added in the scene manager. This whole changing scene isn't too important. The scene manager basically has an abstract update method so that each scene can do different things in the update method. And then the window can change the scenes now just by going and getting this method called and then just literally instantiating a new scene of the specific type we want it to instantiate. And then delta time is literally just getting the time when the scene starts, which is down here, and then getting the end time and getting delta time, which is the time that it took to get from here all the way back to here. So that's all that's happening. If anything doesn't make sense, leave a comment. And the next tutorial, what we're going to start going over is probably some like drawing stuff. Now, we won't be drawing anything to the screen, but I'll be going over how drawing works in OpenGL and how we're going to sort of get that up and running because it's quite a bit of stuff. But I think that's the direction I want to go. So if you guys like this, please hit like and subscribe. And if you want to be notified of when I release new tutorials, then make sure to hit that subscribe button. I'll see you guys next time. Thanks.